Okay, so we're doing learning target 8. I know we just did 6. You think we'd be doing 7, but 6 goes with 8, so probably next year we'll rearrange this. This one's called 7. Whatever. Construct a linear equation giving a real-world context. All right. So this is the same exact problem that we did, except now I'm already telling you what the answers are. So Stacy is selling a bracelet to help support her favorite cause. She buys a box of bracelets for $15. She sells the bracelets for $2 each. So last time we determined that the independent variable was the bracelets and the dependent variable was her money raised. And we're trying to write an equation. And we're going to write it, this one, since it's an independent and a dependent, in the form of y equals mx plus b. But if we want to, remember, so we have this money raised, or this was her profit, this was her bracelet sold. So we can think, right, that everything that she's doing is going to equal her profit. Where is she starting? Where is Stacy starting? Well, the first thing she needs to do is she can't sell bracelets. She has to buy the bracelets. So right here is where she's starting. So my starting point, remember, is my plus B. But if I'm buying something, I'm actually losing money. So I'm going to be losing that money because I have to buy it first. Then I gain $2 for each bracelet sold. So then I can just switch it to y equals 2x minus 15. So here, my profit is, for every 2 bracelets I sell, I'm gaining money, but I have to take away that $15 that I originally bought. All right, here, a minivan is 220 miles from its destination, Flint. It begins traveling towards Flint at 72 miles an hour. So we said that our independent variable is our time, our dependent variable is our distance. So remember, we want y equals mx plus b here, because we have an independent and a dependent. So I am starting 220 miles away. So, if I'm starting here, here's 0, here's 220. So I'm starting 220 miles away. So y equal, plus 220. But I'm going towards Flint. So I'm decreasing my distance. So that means this is going to be a negative. So this would then be, again, this would be my distance is going to equal my negative 72. Oh, wait, no, I have this wrong. Don't do it. This one doesn't really work. You have to do it as y next here. So since I'm traveling towards my 220, that's why my 220 is positive, and I'm traveling towards, it's getting smaller. You could also have it this way. You could have a positive 72x and a minus 220. So if you're saying you're this far away, you're starting away, that would be your minus. The 72, you're getting closer, you're increasing. Or if you're saying this is your distance and you're coming up closer to it. So one of them has to be a minus. All right, Devin is going to the carnival, blah, 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 blah. So remember, this one was variables. This one was our variables. So this means we're going to have like something equals 2x plus 3y or whatever. So we can call Ferris wheel, I'm going to just label this as an F, but then we'll later transfer it to an X. This is going to be my Z. We're later going to transfer that to my Y. So I'm starting with $20. I have $20. With that $20, I can spend $2 to ride the Ferris wheel, or I can spend $4 to ride the zip line. So then it would be 20 equals 2x plus 4y, because I made my Ferris wheel my x, my zip line my y. And then we could solve for x and y if we wanted to. All right. So before class, consider this scenario. Sam has already burned 325 calories before he begins to swim for his workout. His swim will burn 7.8 calories per minute. Define the variables, write an equation in slope-intercept form. Explain which part of your equation, what each part of your equation means in terms of Sam's situation.